Hi, everybody. I'm Will MacNeil, and I'm also known as Will from The Mill. If you're not familiar with The Mill, it's this big international design studio, VFX company. We do all kinds of stuff. A long time ago, we made the visual effects for a movie called Gladiator, and things just kind of went from there. We got into pop promos, commercials, all kinds of interesting work. But I'm actually here to talk about kind of a different bunch of work. And I work in what's called our experience team. I'm a creative director in that team. And it's a really big range of work. And I'm going to just sort of share some of it in a bit depth in this talk. But suffice it to say that it covers pretty much everything that doesn't fit on an ordinary screen. So things I'm talking about, like we made 8 minutes of animation for what was at the time the world's largest video screen for the Beijing Winter Olympics. It was a 160-meter wide screen. We made animation synced up with the dance for the Italian Olympic Committee. This is a project we did a couple of years ago for the Royal National Institute of the Blind. We built a visual impairment simulator for Twitch so that people with visual impairments could play on a level playing field with gamers who had standard vision. And we did use a lot of technology, which I'll describe later, to make that happen. But it's just a really fascinating way of letting people kind of communicate in a new and interesting way. We designed shirts for a football team called Hope United, where we took data about how female players were being treated online, about the kind of abuse they were receiving and the positive comments they were receiving. We scraped that information off the internet, and we built a generative art project that created individual shirts for every player on the team. So lots of really interesting kind of new creative approaches to telling stories and to reaching out to customers. Now, of course, it is a big visual effects company, and I think it'd be unfair if I didn't sort of show off some of the stuff we do. So I'm going to pepper this talk with a couple reels, this being the first one. This is a behind-the-scenes film for a project we just recently completed. So I can say I didn't touch a single frame on that project. One thing I really love in showing these is, yeah, sure, we're a big visual effects company. We have access to a lot of gear, but sometimes nothing beats just getting someone in the studio to run around and shoot them on an iPhone as a reference. Really fun way to do it. So if you've ever seen anything I've made before or talked about before, you know I have a kind of reputation for using software tools to do kind of unusual stuff. And this talk is sponsored by Houdini, so I'm going to be talking a lot about using Houdini to do unusual stuff. So this is a tool I made in Houdini called It, which allows you to simulate the look of real oil painting on a surface. And it can play around with all kinds of custom settings that I put in there that allow you to control how blobby the painting is, how messed it up it is, really kind of control that look and feel of paint. And then it allows you to do something like take a photograph, bring it into the same system, and convert that into an oil oil painting. Now, in this days of things like style transfer and AI, this is not what this is. This is actually a system where you can analyze a photograph and adapt it into making paintings, but you get control of everything along the way. So it's a real fun tool to play with, and I've shared it around with a lot of people who've done cool stuff. Once I realized that I could take photographs and turn them into paintings, I thought, well, maybe I can take data and turn that into paintings. So this is a system I built called Distral, which you type in a city, it gets the weather from that city, and then we'll turn that into a painting like this, kind of give you an idea of what the weather feels like. I got really excited about this whole idea of sort of customized tools which allow other people to input information and then make something of their own. So then I started looking at data in virtual clothing. Could we use data to change the way or give someone a unique custom piece of clothing? So this takes data off your wearable device, like an iPhone or a Fitbit, and then turns that into a personalized design for you. Same thing with scraping your Instagram feed and finding the colors you like the most and creating a custom pair of shoes. So this stuff is all kind of, building up on just an idea and taking it and seeing how far you can go with it within a tool set. And then a few years ago, we were approached by this company called Vivo with this really interesting idea of, we want to make custom shoes for people in a shop where we scan their foot and we 3D print a shoe in the shop for them at the same time. So we used Houdini and we built this system where all you had to do was input a new foot scan and you got a new shoe. And that shoe was customized to your foot. It also included some special kind of adjustments which were used to kind of encourage you to wear shoes in a more kind of appropriate, comfortable way. We just found out recently this has now become a product. Vivo are now releasing the world's first 3D printed, mostly biodegradable custom shoe. So this thing that we did as a kind of test for them a long time ago has now become a product. And I think that's just so exciting that something that started out as all kinds of interesting ideas has now made its way into a product, which may actually turn out to be quite important because of the biodegradable aspect of it. So all of this stuff, this weird projects, these things that involve things like API calls to other servers, data transfer, custom interfaces, and loading in photographs, all that stuff is just kind of what makes me so excited about making art now, is it's because it's not just putting something out there and saying, have a look at this. It's saying, here's something that you can play with and you can change. So that's kind of my approach to using tools like Houdini in general. And I thought I'd just kind of explain a little bit in a very simple way about how some of this works. So when you make something in Houdini, you don't just make it once and then it's done. You actually build a tool set around it. So I was just playing around with, what could be another tool set? What could be the next thing with painting? And I came up with this idea for ripped paper, because everybody wants to make motion graphics with ripped paper one time in their life. Why not make it easy for them? So I built this tool inside Houdini called Rip It. And it's just starts with really simple things and builds up. And I think that's something that's a kind of a theme in my work, is you start with really simple stuff and then you just make it more and more complex until you have something that feels kind of realistic and detailed. So this just starts with a square, a grid inside Houdini, and then a line which you can draw and rip the piece of paper. Every time you rip the piece of paper, you make that line, you get a different rip. You get all that different detail inside it. So this line has to be, carry so much kind of almost microscopic detail in it. So after you draw it, we go in and add a lot of noise to that to give it all that kind of subtle disturbance inside to create something that really feels like it's ripped at a microscopic level. That's then extruded, makes a cube. That cube then becomes a cutter. So basically that becomes like a container that you can use to cut things with. And then it cuts this little piece of paper. Okay, so pretty simple so far. To get that really nice rough edge on there, where the layers of paper have come apart and you get all that sense of the different types of paint in there, paper, which really makes it feel like a piece of paper. I created these three little interfaces. So each one of those can have a different texture on it. So it feels like you're pulling apart something that's actually made up of layers. And if you look closely, you can see I've added the ability to kind of dial in randomness into that. So to create kind of your own custom controls. So you never get the same thing twice, and you always get a little bit of a kind of more random design. And one really cool thing about working in Houdini is that it's procedural. So basically, if you build something for one side of the piece of paper, you just copy those bits, those nodes, over to the other side of the piece of paper, and you've got the other side done. You just change a few parameters, and it works on the other side. It's fantastic. It's really a lovely way of working. If you look really closely, there are all these little kind of tears and fibers in there, and that's because paper is made up of fibers, or at least I think it is. So I've just made thousands and thousands of little tubes that sit right on the edge of that, and that's what creates that kind of almost fuzzy look on the edge of the paper. Typically, when you work in 3D and you add a lot of detail to something, the scene gets very heavy. So a really important thing is to constantly play with switches and things so you can turn that off and on. So you can work without that extra little bit of fuzziness until you need it, then you can switch it back on again. There's another one here which just turns on and off this bend deformer. And this is all just trying to make this tool just feel really fun and easy to use and create something that looks good every time. And so then finally this whole setup goes into Houdini's Karma renderer, which is just the inbuilt renderer inside it, which is lovely and fast, has great things like shallow depth of field that you can control really well, and works really well for something like this. You just get lots of lovely little detail. If you're into render engines, this Karma, it works across CPU and GPU, does the same thing, same results. Really fast, intuitive controls. I love working with it. Finally, this is what it looks like at the end. I spent a while trying to figure out what would be the best kind of frame to sell this, but I came up with this one. Not sure if that's great or not, but seems to work. But this is an idea of just how many kind of nodes go into this. It's actually not that much to build a setup that can be used over and over again like a tool that you can use to make all kinds of different things. So that's the Rip It tool, which is kind of my only real kind of close-up demo I'm going to do today. I'm going to show another piece of mill work now. I'm going to cut it off about halfway because it has the most repetitive piece of music on it you've ever heard. And then I'm going to talk about some other stuff. Okay, I'm going to stop there because you've all probably memorized that music for the rest of your life now. So sorry about that. It's really interesting to see how much work goes into a piece like that, because it actually, when you look at it, you think, that looks like it's done in camera, but actually a huge amount of stuff has to go into painting things out, recreating detail. You might have noticed we actually had to add someone's hair back, so we actually had to 3D render hair for that. Big job, and I think it turned out pretty cool. So another bit of mill work. This is a quote that I think is particularly interesting now. It's actually 15 years old. I possess a device in my pocket that is capable of accessing the entirety of information known to man. I use it to look at pictures of cats and get in arguments with strangers. This was said about mobile phones when they first came out, or smartphones, because we have this incredible piece of technology, and we tend to use it to do quite dumb things, or things that we could always do. And now here we are 15 years later, and this is a video made by a tool called Sora. Some of you may have heard of it. It came out from a company called OpenAI. And what's happening here is basically a computer system is taking a text prompt from a user, and it's turning it into a video. And here we are again, 15 years later, and we're making cats. Or pictures of cats, sorry. Now, I come from a world where computers are enablers. They are the things that allow us to do things that sometimes we couldn't do. And I started using computers in the 80s, early 80s. And when I was doing that, it was because I was desperate to make imagery, but I wanted to have kind of infinite levels of control. I wanted to be able to do things that I couldn't do with a pen and paper because I was just, at the time, just unable to do that. And you had to work extremely hard to do this. You had to get access to a computer. My school of 800 students had one computer. That's the one on the left, the Texas Instruments computer. You had to get as much time on that as you could possibly get. It was extremely difficult just to access it. And then that's the kind of thing you could make on the right, a star. It took ages to kind of make anything, but it was fun and it was interesting because you were engaging with it and you were doing something that you loved. Now we have these companies that have all the computing power in the world. I mean, they have more computers than it's possible to imagine. They build warehouses in the middle of nowhere, fill them with computers. They have endless amounts of money. They have endless amounts of energy consumption. And what they come up with is tools that do things that we can already do. Now, I'm not against AI, and I'll explain what I mean in a minute, but it really pisses me off to see companies doing this. Basically, to use up all those resources to do something that's so boring and so uninteresting and that we can already do. This is another example of something that was done with AI recently. If you're in the UK, you may recognize this. This is the Willy Wonka chocolate experience in Glasgow. So these are the marketing images that came out. Now, if you use AI now and then, you probably realize when you look at these images, they're from a tool called Midjourney. Now, that's a system, again, where you can type in some words and it'll make a picture for you. It gives the impression, when you look at it, that actually there's some money behind this, that there is a company that has hired some graphic designers and illustrators to make some branding work, and that there's something actually worthwhile here to look at. If you look more carefully, you can start to see some problems, like spelling errors that they never bothered to fix, that came out of Midjourney. And if you look really carefully, you realize the whole thing is absolutely shit. This is the actual experience. They got people to pay £35 a head to do this, and it's absolutely rubbish. This is one of the actors who was in it playing an Oompa Loompa. She was so distraught with this whole thing that she actually went on social media and said sorry for taking part in this thing. But what's really interesting about this is how it generated a lot of new knowledge about AI, because the parents who took their kids and paid £35 to take their kids to this revolted. And then they said, we're not having this. We're not paying £35 for this. This is in Glasgow, so you can imagine what that's like. They got their money back and they got the whole thing shut down. And they also found out that the event wasn't even licensed. They didn't even have the right to use the Willy Wonka name or anything like that. Another nice side to this story is that this woman who played the Oompa Loompa is now getting paid in America as a bit of an influencer to talk about that experience and actually recreate it in the US. So the whole thing's had a kind of weird kind of flip side. The whole thing feels a little bit like some sort of Banksy art project. But what I think is really important here is that people started to realize that AI can actually be, if used incorrectly, is a source of dishonesty, because it can be used to trick you into thinking that something has value or has artistic merit that doesn't necessarily have that. So what can you use AI for? Well, so these are some things I mentioned earlier, which I think are really interesting. This is our football shirt design. So as I said earlier, we scraped information off the internet about how a group of 4 women professional football players on the England women's team were being treated online during a tournament. So you can imagine there are tens of thousands of Twitter posts and other kind of social media posts made every day. It's not possible to manually analyze those or even to capture them all, but using AI it is. So they used a tool that had been custom built by a criminology team in Wales to go online and read all the tweets about these 4 female players and grade them, whether they contained sexism, homophobia, or racism. And then we plugged all of that into our design system to build this generative design for the shirt. So each player gets their own shirt. And what's really neat about this is, first of all, we had suddenly all this information to feed to the public about what was actually happening. So the sponsors EE could run a website where you could see more specifically about what was happening to each woman at each different match along the way. This is the Euros that occurred a few years ago that the England women won. But actually, it turned out to be a really positive experience because you could also see that there were about 10 times as many positive tweets as negative ones. The negative ones were horrible and they were kind of disgusting, but there were many more positive ones sent. So it was just really interesting to see what the machine learning was able to find there. This tool I mentioned before as well, this Royal National Institute of the Blind piece, this uses a visual tracking system called MediaPipe, which is an AI machine learning tool made by Google, which is used to add control over a phone for people with disabilities, things like that. We used it to make these eye simulations, these visual impairment simulations, as realistic as we could. So for instance, when the player moves their head or their eyes, the distortion tracks with them. So it isn't just some filter that we stuck on top. AI allowed us to make this thing very interactive. And it was still lightweight enough that we could put it out over Twitch and make it work. Some more interesting examples, back to Houdini here. This is something I made a few years ago. This is an island generator. So basically I just wanted to create as many fantasy islands as possible. And then using Houdini, using primitive tools and procedural tools, you can basically, once you come up with that kind of outline, you can create lots and lots of different versions of them. But then I thought, wouldn't it be fun to come up with some interesting way of naming all the places in them? So I approached a tool called ChatGPT and decided to just come up with names for all the little places. And being extremely mature, I asked it to come up with rude names for all the places. And this is really interesting because it does that, and it does it really well. But whenever you deal with AI, you've also got to be really careful that it doesn't come up with something that's just extremely rude. And it worked out pretty well. But while I was doing this, I realized there's another thing we could be doing with this chatbot inside Houdini. Now, if you work in 3D, you know that one thing that we spend a lot of our time doing is kind of trying to bridge this gap between our artistic sensibilities and the computer's kind of digital numeric way of dealing with things. So for instance, when we talk about colors, we tend to talk about RGB values rather than what we think the color looks or feels like. Well, using a chatbot, you can bridge that gap, and you can tell the chatbot to create a palette based on a color, and it will do it. So this is working inside Houdini. This accesses ChatGPT through an API, which means it's reaching out to it externally over the web. And you just type in some words, and it comes back with a palette full of colors for you, which is quite helpful. And if you imagine all the different things that you do in computer art that require you to kind of to think in numeric terms when you'd rather think in terms of color, texture, meaning, this is a kind of way towards doing some of that, which I think is really interesting. This is another tool which I made inside a piece of software called Touch Designer, where we're creating shapes and animation in real time, responding to basically me dancing in front of my webcam. That's me in the top left. So this is real time, and it's in front of a webcam. So, there's no kind of rendering going on here. This is happening straight away. So a couple things that are interesting that are going on here. First of all, I'm being cut out by this in real time. The rotoscoping around me is happening in real time using AI. The text prompts, which you can see along the bottom, are actually being randomly generated by ChatGPT. Whenever I hold up my hand and make the V sign, it generates a new one right away. Get a new prompt. That prompt is also feeding into the palette, which is in the bottom left. So every time I make the V sign, it creates a new palette, a new prompt, and all of that stuff. And you get this really fun animation, and it's extremely fun to play with, I must say, having just played with it a little bit. But you can see perhaps where this might be going when we get a lot more control in the AI system. This is Stable Diffusion, by the way. Once we get kind of more control, more stability, more kind of consistency, visual consistency, this could feed into all kinds of things you might see in a shop where you want to try on some clothes, or more fun things where you're in a shop and you want to kind of get a whole kind of brand experience around you. In a museum where you might want to visualize yourself as some kind of other creature or entity. Any kind of learning experience. And what's really interesting about this for me is it's all gesture-based, so you don't have to touch anything. All you have to do is learn very quickly just how to hold up a hand signal, and you can do all kinds of really simple controls just by using your hands, and that's AI as well. So all this kind of stuff about making, copying people, ripping off imagery, I think it stinks. But there's so much fun stuff you could do with this, and that's what I'm trying to experiment and find out here. So I have some rules that I apply about how to use AI, because it's very easy to end up doing what I would consider to be the wrong thing. The first one is don't steal. Don't rip off other people's work. Don't enter a prompt of another artist into an AI tool like Midjourney and say, make that for me, and then present that as your own work. Don't make an artist redundant. Don't take away someone's job just because you can or because you think you can. That's not fair. That's not cool. We work in an ecosystem where every artist matters. Every person, from the most junior artist up through senior artists and all the administrators who go into this, they all matter. We can't just take someone out of the equation because we think we can jump over their skill set. don't support negative stereotypes. This is something that's a little bit subtle, but AI tools generally only make things that have been made before. So if there is something like racism, sexism, or any kind of discrimination in the image set or information set that's fed into an AI tool, that's going to come out when you see it, when you use it. I did a test recently about on Midjourney of just making images. I said, make an image of a boy in a war-torn street. I didn't specify that boy's race, but he came back as an African boy in all the different options. So, beware of that stuff, because it can catch you out. And this is the one that really matters to me. It says, don't undermine human creativity. And this is the one that gets me every time, is that the whole point of what we do is that humans made it. We're here because, we're artists because we want to tell our stories. We want to share our version of the world. Just because you can get a computer to do it doesn't mean you should. I do think you can get a computer to help, and that's where I'm finding this, interesting, and get the computer to help you tell your story in more interesting ways. So, how are we using this stuff in practical sense? Well, here's an example of something we did for an ad about a year ago, where we were required to make a lot of map paintings for a kind of futuristic cityscape. So more than we would normally be able to make on a project in a normal period of time. Lots of different angles, views, lots of changes in art direction, all that kind of stuff. So inside Houdini, we used a tool called MLOps, which is really just accessing another tool called Stable Diffusion, which I've mentioned before. So here's how this works. You start with a grid. Again, I always start with a grid. And what I'm doing here is just making a simple cityscape. So I can subdivide that grid up into lots of different pieces, lots of different squares that represent lots of different random building height or building profiles. And then I can add some streets in there that make little bits to make the grid of the streets. Then add some extra streets that are a little bit more random, just to give the whole thing a bit of randomness. Then extrude all of these up in another random way. So now these squares have become cubes or rectangles that are vertical, have different heights. And then take just a simple asset bought from TurboSquid of lots of different city buildings. And then right away you've got a really simple city generator. Now there's no way this is going to make its way into a final 3D scene as it is. It needs to be textured and lit and comped, and all kinds of things need to happen. But for a map painting, this is getting you started. And you can play around with the camera, the points of view, the composition, and get lots of different options here. And that's what I did, just playing with lots of different ways of framing our scene, different profiles of the skyline, all that kind of stuff. And then doing what we call AI rendering, which is basically feeding simple information into the AI system to get more complex information out. Basically putting a grayscale image into it and getting a more rendered, lit version out. And we've tried this on lots of different stuff, and you can get all kinds of different control. There's something called ControlNet in Stable Diffusion, which allows you to guide it in a very specific way. And that's what we're doing here. And so here's an example of kind of the before and after. You see on the left side a cityscape of buildings that I created and rendered as grayscale. And I was able to create this very quickly. And on the right is the sort of map painting that Stable Diffusion generated. And then we get lots of different options. If we want to change a shot, we just change the camera in the original grayscale, and you get a different look. And you can play with some other parameters to get different looks out of it. And we get lots of really nicely detailed map paintings. But the big plus here is because we built this using a 3D scene that we created and started with, we still have all that information in our shot. So we can determine the depth, the height. We can figure out things like the layering, what building is in front of what other building, all the occlusion, things like that you wouldn't get if you just started with a painted map painting. Again, we change the camera and you get a different output. Sorry, my Siri is going off. Telling me I'm being stupid. We can, get lots of different looks very quickly just by running it through Stable Diffusion again. Now, Stable Diffusion is an AI system. It's built on a training data set that contains hundreds of millions of images that were never licensed. So in theory, what's going on here is a bit wrong because you're taking other people's work. What makes this a little bit different is it also contains the ability to train it for very specific types of work that you're working on. And we call that a LoRa, an adapter. And you can train a LoRa on about 30 images. So basically, if you have artwork that you own, that you're concept painters worked on or that you have from a previous job that belong to you, you can train the AI to use that. So you're not necessarily, no, you're not stealing somebody else's work because everything you have in there is yours. You're also not taking away a map painter's job because this whole process integrates a map painter in just another way. Map painters are still involved in this process. They're still going to pick up and take these shots and do more work with them. Here's just another example. So again, training our own models using adapters to make sure that what we've got here is ours. And by the way, for us, that's also a legal requirement. We can't just put out work without doing our own training for it. But this allows us to do training in a very small way and not replace the whole training data set, which would be impossible. So just to kind of dial back here, don't steal. I don't think we did. I think we used training to replace things and use our own artwork to feed into this. We didn't make an artist redundant. This incorporated map painters to make map painting. Negative stereotypes. You could potentially argue that a futuristic city like this is a slightly dystopian stereotype, but I don't think that's really an issue here. And don't undermine human creativity. We worked hard on this. We developed systems to make it. We're going to use those systems again. So basically, we feel like we're being artists here. This is our work. This is not us saying, actually, our work is rubbish. We can get a computer to do it better. Okay, it's the end of the bit on AI. I'm just going to show another 1.5 minute long video and talk about one other project that we just finished.
When we look at things that we consider to be beautiful, the activity in the pleasure and reward centers of the brain goes up.
Sometimes you can be overwhelmed with feelings, but you don't know where they're coming from.
I think just any reaction that it evokes, that's like momentous.
Studies suggest there is a release of dopamine, which is also known as the feel-good neurotransmitter.
It's mind-blowing. It takes me into another world.
And the art can take me there.
It's just like, wow.
So we were asked by a charity in the UK called the Art Fund, who have an art pass which allows you to pay one fee and then go to lots and lots of, well, thousands of galleries around the UK to contribute to this project that was going to help kind of try to encourage people to come back into art galleries after COVID, when people had been kind of switching off a little bit. And so just to be clear, what we did here is we built a real-time animation system that took information coming from your brain and turned it into animation that basically was live. And that animation was designed to kind of show you a little bit about what was happening in your mind at the time. And we basically wanted to, well, we did put these in galleries and have people walk around a gallery, look at cool art. Like here, this is the Hayward Gallery in London. And record these brainwaves and these animations in real time and show them back to them. So what's really fun about a project like this is you really have to invent everything as you go. We're not NASA. We don't know how to do this stuff. We're not neuroscientists, sorry. We don't really know exactly how to do this when we go into it, so we have to figure stuff out. And the first thing was, how do we get a device that we can hack into that's really easy to put onto someone's head, isn't scary, and that we can actually get some information off of. So we came up with one of these. It's a Muse 2 headset. These are sold mainly for biofeedback when people are meditating, to kind of help you get into a more meditative state. But they actually have a really lovely side to them, which is you can hack into them and get at the raw data stream coming off of them. And they're only £225 on Amazon. we had to figure out what kind of information we could actually get off of one of these things that we could turn into something meaningful. Because, neuroscience is a pretty big field. There's a lot of discovery going on all the time. What could we do that actually would tell people something interesting? So we did some tests. We went inside the mill and we got as many people as we could to sit in front of a slideshow of art and see what they saw, what was happening in their brainwaves while they were looking at art. And we just recorded that raw data. And we started to build some spreadsheets like this. The rather frustrating thing that we discovered is that the biggest differences you see is from one person to another. And then massive differences, especially depending on people who might be neurodiverse. You can really see that. We had someone with ADHD who was really giving us some very different numbers. It was very interesting. But what we really wanted to see was what was happening to a person over the course of them moving through a gallery. So that took a lot more figuring out. How could we understand what was actually happening to them rather than comparing them one person to another person? So we came up with a few kind of bits of science that suggested there were signals that we could look for in the brainwave data, which is processed very heavily, that would give us some information about what was going on in the head. Particularly two things. When someone saw either a confusing image that they had to spend a while figuring out what they were looking at or trying to figure out what they were looking at, and the other is when they saw something familiar. And both of these gave very specific but hard to detect signals inside the processed brainwave data. So we built these triggers within our animation system to identify those and then make those things affect the way our designs worked. Meanwhile, whenever we do a data visualization project, figuring out like how you're going to tell this story is a really interesting process. So these are references that we just put in front of the clients and we all discussed about how many different, what would be a good way to tell this story where we want to make sure people understand it's about data and also understand it's about art. And we decided that, putting actual art into this wouldn't be right. It would be confusing, the kind of metaphor. But we looked at some stuff like this and references like this kept coming to the fore and we thought, well, these would be fun. This kind of ribbon approach could feel a little bit like a timeline, almost like a ticker tape flowing out. So then when I start doing initial designs for stuff like this, what we're going to build eventually is an application that's going to work in real time. But that's not a very good way to design stuff. You need to be in a place where you're comfortable designing. So these are my frames which I built inside Houdini. And I started out with this kind of ribbon idea, very much like a plot on a timeline. And then started to think about what we could do to that to add real interest to that. What could, by bringing it into 3 dimensions, what story could we tell? How could we make this information more expressive? Whenever I do data design work and I do the initial frames, I try not to just randomly build stuff and go, oh, that looks nice. I try to actually build a system that we can plug numbers into and see what happens. So right from the beginning, we've got a kind of hybrid approach. We're designing, but we're also looking at how data works in this system. So this is a kind of idea of how this works inside Houdini. This is this ribbon system, and if you look carefully, you'll notice that there's some turbulence in there. That's a cloth simulation that's starting to make that move. And that was just something I thought, well, that could represent something. That could describe something in the brain in a really interesting way. So I was thinking ahead about the various streams of numbers we'd get and what we might do with that stuff. So, for instance, one thing we could change is just the width of the ribbon at different places. Okay, now what would that mean if we did that? Would that mean that somebody's more interested, more excited? We started to think about the kind of value ranges that would go into that. If we play around with the turbulence and the cloth simulation, how rough does it get? How intense does it get? And all of this stuff it just feeds into our data storytelling so that we come up with something that looks interesting and beautiful, but also can help tell a story. These are some more of my frames. We looked at some literal design language, like adding kind of numbers and plots into that. But in all honesty, those didn't actually mean anything because it was impossible to put values on these. The ranges were just too enormous from one person to the next. Some more style frames. So these are all the things that I built inside Houdini. I built these offline, so to speak. None of this is real time. But then here's what happens when we put it into our generative real-time design system. So this is now a real-time system. This can play back immediately. As soon as the data is piped through it, you get this right away. And you can see this thing called this corkscrewing effect, where the ribbons turn to sort of wind around each other. And that's triggered by a neural pattern called P300, which is believed to tell us when somebody is confused or trying to figure something out. And that was typically would see when someone was looking at abstract art. There's this kind of process that everybody goes through when they see a piece of abstract art, which is very natural. For people, the first moment they look at something is to go, what is it? Is it a landscape? Am I looking at an animal or something like that? And then eventually that kind of stops, and they just stop trying to problem solve and take in the art as abstract art. There's another piece here, another trigger, which is called N170, which is when somebody sees something that they recognize, and you can see that kind of bright glowing in there, that subsurface glowing effect. That's just another kind of layer that we added to this to give it meaning. I mentioned this was in the Hayward Gallery, which if you ever get to London please go to. It's absolutely full of amazing art. And we got to run this test inside. This is us inside. I'm sorry, did I say the Hayward Gallery? It's the Courtauld Gallery. Sorry, the Hayward's something completely different. This is us. We had a big media day. We're trying it out. That's Seth on the left. He built the real-time system, working with me. And we got to try out all kinds of things. We had journalists in there. It was really fun. And from here, the project's going on tour. It's going around the UK. We've managed to get it streamlined down to just a laptop and a headset. It was a much bigger contraption before that. And so it's currently traveling around the UK, doing lots of interesting things. That is it for me, for my talk. Thank you.